All right, we're just beginning to set this part up here, and I've already put it in the chuck and indicated it in. You can probably, I'll show you a close-up of the indicator, and I got it running true up here, but I was thinking about this, and I see a lot of people do these kind of things with steady rest, and with this kind of a steady rest, these hydraulic steady rests, they work good, but they won't necessarily keep something perfectly centered if there's unusual forces on it. What do I mean by that exactly? Let me move the camera over here and get a better shot of the indicator here and the whole thing, so you can see closer up, and I'll show you what I'm talking about. And I'm rotating the part with the C-axis with the handle jog wheel, and you can see we're running pretty true up here close to the chuck on this diameter right here. Less than 1/1000th of an inch, which this is just roughed out right now, and that would be plenty adequate to start turning. But let's go down here towards the steady rest up here, and I'll put the indicator right here. You jog it down here. And I'll run down here till I get a reading on the indicator. I'm gonna go up to 100,000ths on the indicator here, and then we'll rotate the part here. You can see there's I don't know, a little more than 3.5 thousandths run out maybe here, right here, which would be an indication that there's something not right here, because this should be running true to the rollers of the steady rest. Obviously, you know, the steady rest is pinched down on the part right here, and it should be running true, but it's not. And this is the issue some people run into with steady rests, and what you have to be careful of, particularly with hydraulic steady rests, because they kind of can flex around a little bit, because it's just well, there's a wedge device in here that's pushing on the jaws, which the jaws on the other ends of the jaws have rollers on them that ride on a cam, and it controls the centering of these three jaws as they open and close for different diameters. But you know, it's kind of like a hydraulic chuck. You know, when you turn it faster, the jaws can open up from centrifugal force, and it's sort of similar on a hydraulic steady rest. If there's forces acting against these rollers, it can actually move around in here and not be perfectly centered. Generally speaking, it works pretty good, but if you're this close up to the chuck, like there's only maybe a little over a foot, maybe 1.5 feet, 18 inches or so from where we're chucking onto it here, and chucking on this big diameter flange, there's a lot of force that can be applied to the steady rest if this part of the end of the part is not running true. So it's important to, even though you would say, okay, now I've seen guys do this with a hydraulic chuck. They'll put the part in and they'll close down on the steady rest first, close the chuck, then open and close the steady rest. But that won't even really correct this problem, even if you're running a 3-jaw chuck and it's already centered pretty good, because the part can have a slight bind in it, or it can be pointing off axis coming out from the chuck. And although the steady rest is forcing it down into center as best it can, this part can kind of wobble around as it's rotating. And although you'll be turning kind of centered, I don't know if this is kind of hard to explain, you'll be turning centered, but there'll be a vibration that's introduced anytime if you're boring, in particular on something on the ID work, or in this case I'm going to do milling some holes, drilling, tapping some holes in the end. The holes won't run concentric to the turning necessarily, and the finishes on your turning could be bad because you got this wobble, and in extreme cases you can even damage the bearings on the steady rest, particularly if you turn some higher RPMs on a bigger diameter. These bearings can be turning very fast on the rollers on the steady rest. So the important thing to do is make sure that you're running true before you close this, or you have to open the steady rest, I should say, at this point. So let me open it and we'll see what happens. You can see already the indicator jumped as the jaws are coming open. I hope they don't hit the camera here. Might have to move the camera. No, it's going to clear. Okay, so now the jaws are open, and I'm going to rotate the part again. Now, obviously, if your part was real heavy and you didn't have too good a hold on it, you really couldn't do this, or if it's long, you know, like if it's 6 feet long, you couldn't open the steady rest. You'd have to deal with it other ways. But on this shorter part, the chuck can hold it. So I'm going to rotate it. We're going to see what kind of run out we have at the rollers. So we've got almost 10 thousandths of an inch run out with, well, maybe about 8.5 thousandths with the jaws open. So these jaws are forcing, because you saw it was about 3,000, or it was about half that amount of run out with the jaws closed. So you see that we're putting kind of a force on the steady rest, or the steady rest is trying to center the part, but it can't, because the force from the chuck is causing this part to run out. If I run out to the end of the part, I'm going to jog it out to the very end of the part. And you can see the run out we have here. See, it's like over 10 thousandths of an inch. So what I'm going to do is I'm going to jog it to the, this is, the indicator is deflecting upward when the needle moves this way. So I'm going to jog it to there. See if I can move this thing with the hammer a little bit. It's held pretty tight. I've got the chuck jaws pretty tight. Okay, let's see what we got now. It's better. Gotta still go a little more. Let's go up to the maximum here. Kind of hard for me to hit it as the cameras, everything's kind of in the way here. So the idea would be to get this to run as true as possible. Out here. But before we get too carried away, I'm gonna stop right there, and I'm gonna go back up here to the chuck. I have to raise the x-axis a little bit here. Got a fairly good diameter change from 4 to 6 inches here, so I got to move up and down. I'm going to check this out here again. This will probably be running out a little bit now. Not too bad though, really. I'm not going to mess with that too much. This is just roughed out, so that actually is plenty adequate for the run out down there, but I want to get this running better down here out at the end. I'm going to come back up to 0 on the indicator, jogging the x-axis. So I'd like this to be better. Now the steady rest will probably push that centered, but there's, even with that little amount, there's going to be a forces on these bearings that causes problems. Sometimes if you can't move this, you have to hit it with a metal hammer. I'm hitting it with a dead blow, this hammer here. Dead blow hammer. Sometimes if you can't move things with a dead blow hammer, you have to a metal hammer will actually work better, you know, like a copper, brass, steel even. I mean, this is all roughed out, so I'm not too worried about denting the part, but these chuck jaws really have a good hold of the part here. I'd like to get this within a, see, we're running about, what, 3 thousandths almost? Yeah, about almost 3 thousandths there. Man, I don't really want to loosen the chuck jaws. I know that this is pretty straight because I turned this all at once in one setting with the tailstock up here. So, you know, you can have run out between diameters on here and you'd be fighting that as well. But I know that this is pretty straight. All right. That might be about better. Okay, that's quite a bit better. Now what I'm going to do is close the steady rest and see what we're doing. You might see a little jump in the indicator when the steady rest clamps down, depending on how centered it is with the actual spindle. Not too bad. And now you see we're running pretty true. Now, I mean, this is probably plenty adequate for this. So what I'm going to do is face the end of the part and do my end work. There's 4 3/8 tapped holes in the end, and then a 1-inch hole and an 1.25-inch hole with bored and chamfered so that my steady rest will run. I mean, my center, excuse me, will run true. And then I turn the whole OD of the part and finish it. But if you don't do this, you're going to have vibration develop on this steady rest and everything, and particularly when I go to bore this hole in here, it screws up the finish of it, and then everything can be running out in relation to the chuck and the spindle, and you're of course putting force on the spindle bearings, but this big spindle, it could take that wouldn't really be a problem. But when you put your live center up in here, it's going to have force on the bearings of it, and everything is going to be not running true. Even though you think it is, you're running out in relation to your center, because your center is being forced off center and wallowing, and you know, it's not rotating in a circle basically. So it's important when you using a steady rest like this to make sure your part's running true out here without the steady rest on it if you can. On a short part, that's possible like this. On a longer part, it's not as possible, but you have less forces you're dealing with out at the steady rest end if you're 6 feet away out here. And with a short part like this, as you can see how hard I hit it with the you know, with this is a 4-pound, I think it's a 4-pound dead blow hammer, and I was hitting it hard just to move it. So that's how much force the steady rest probably isn't going to put that much force into the spindle and everything to make that part go in alignment. And so you're going to be vibrating the bearings in here, and in extreme cases you can actually see these jaws moving from the force. And I don't like to run a lot of high pressure on the hydraulics of these steady rests, because all it does is it makes your bearings in the rollers wear out faster. So I don't know, I thought I'd show that. That's just a little thing that's important to do that a lot of people don't really do, and they can run into trouble. Let me check it back here. Although in reality it's not as critical that this be running true back here, as long as there's no run out there forcing the bearings of the steady rest to run out. Let's see what this is doing now. I could adjust the chuck a little bit here if it's running a lot. It's running out a lot, but If it's running within a thousandth or so, I'm not going to mess with it. So it's pretty good. This is good enough for this purpose because this is all gonna, a quarter inch is gonna all come off of this. So it's not too critical. And also, if you have a big flange like this and you're putting a lot of force, the minute you release this chuck, you know, because the steady rest is trying to push it in the center, your flange out here is not gonna be flat anymore in extreme cases. When you turn the other side of it, your thickness is gonna vary. So those are all those things are something that need to be taken into account when running parts on a steady rest like this. All right, I've set this 0 to take about 50 thousandths off as a facing cut to clean this face up. Face is just the raw sod surface. I didn't bother to face this when I was roughing it. So I've allowed stock on the flange over here, and if I take 50 here, this should clean up over here on the face of the flange.
Mm-hmm.